Dear students, welcome back. This is Dr. Biju was the course of discussion is Calculus 1, Math111. This video is the second part for week 12, in which we will discuss the chapter 4.2, Analysis of Functions 2, in which we are going to discuss relative extrema. Extrema is the common word for maxima and minima and graphing polynomials. Okay, what is a maximum minimum? A function is said to have a relative maximum at x0. It is relative maximum, isn't it? At x0, if there is an open interval, assume that this is the curve of a function, and this, assume that this is the x0 and the x-axis, isn't it? This is y-axis. So if you want to say in this locality this value of f of x0 is maximum, so there should be an open interval in which every f of x, every other f of x will be lesser than this value. That's given here. If this condition satisfied, then f of x0, this point, is the maximum value. So there are many local relative maximums possible. In the similar way, you can define for local minimum. This graph roughly shows you how you identify a relative maximum. There are many relative maximums. So this one. There are many maximums in the locality of this one, isn't it? But out of which this is the highest point, absolute maximum. And this is absolute minimum. This minimum most point. There are many minimums, which is called relative minimum, isn't it? So how to identify the relative minimum and maximum, we will see. This definition. Suppose that a function f is defined in an open interval at this point. Function should be defined at this point. The given f should be defined at this point. And if there is a relative extremum at x this point, then this point is called critical point. That is, relative extrema occurs at the critical points. Critical points are those points at which first derivative does not exist. If exists, it is 0. If I give you a function f of x is equal to x square plus 2, you can find first derivative 2x. So first derivative exists, but it should be 0 to find. So you can put 2x equal to 0, then x will be 0 is the point at which there will be either maximum or minimum. You can find extrema. So if first derivation exists, we have to take it 0 to get the critical point. If first derivation does not exist, then still that point is also a critical point. What's the difference? See, all the points at which first derivation either does not exist or 0 is called critical point. But those points at which first derivation is 0 is called stationary points. Stationary points. So every stationary point is a critical point, but every critical point is not a stationary point. We should remember this one. And now, point of non-differentiability. See, when there is a sharp edge, there is no derivative. We have seen this one for the derivative of f of x is modulus x. It's a curve like this v, and it is not differentiable at 0. We have seen this one, isn't it? Because left limit and right limit will be 0 for different value for the limit definition of differentiation. So in the similar way, every sharp edge, at the sharp edge, the function is not differentiable. And in this kind of horizontal tangent line, you will find differentiation slope is 0. So derivative exists but 0. So these are the points at which derivative exists but it's 0. But these are the points at which derivative does not exist. So there are 5 points here, out of which, see, 4 are critical points, but 3 are stationary points. See, x1, x2, x3, x4 and 5. See, that is all the points are critical points. x4 and 5, x5 as well, isn't it? All the points at which either the derivative does not exist or if exists, it is 0. So at all the points here, derivative 0, derivative 0 here, derivative 0 here, at these 2 points derivative does not exist, isn't it? So all the 5 points are critical points, but these 3 points where derivative is 0, first derivative is 0, x1, x2, x5 are called stationary points. So this graph gives some idea about this one. See, here first derivative is 0, so critical point and stationary point and relative maximum. So this is the maximum value of this function, isn't it? No more maximum possible. So this is the relative maximum here does not exist. What is it? Derivative does not exist. So it is not it is a critical point, not a stationary point. For stationary point, derivative exists, but it is 0, and is still maximum, relative maximum. In this case, this is minimum. Minimum value of this curve is appearing here. At this point, the first derivative is 0, so this is stationary and critical point as well. Here again, it's critical point but not stationary because derivative does not exist, and minimum, relative minimum. Here again, horizontal tangent line, but this, see, there is no minimum or maximum. This is the middle of this curve, so neither not relative extrema. Critical point, stationary point of inflection. We have seen point of inflection. What is point of inflection? In the previous chapter we have seen where the concave down changes to concave up, or concave up changes to concave down, the point at which second derivative is 0. Okay, this is also inflection point, and there is no maximum, minimum, critical point, stationary point, everything. See, whenever there is a vertical tangency, that is not a stationary point, it's a critical point, isn't it? This is a derivative is infinity, so critical point but not a stationary point. And of course there is no minimum, maximum, and inflection point, same as here. And first derivative test for finding relative maximum and relative minimum. What is the first derivative says? F is continuous at a critical point x0. So one point is been given x0, and f is given, defined and continuous at this point, isn't it? If first derivative is 0, is positive from left, negative, okay, what they say, x0 is a point here, isn't it, on the real line. This is the point x0. Okay, if first derivative is there is an open interval about x0, first derivative is positive on open interval extending left from x0. In this side, left side, first derivative of x is positive and it is negative here, first derivation. What is happening? When first derivative is positive, the function is increasing. First derivative negative, the function is decreasing. So the function is going up and coming back, so it should be the maximum. This point at x0, function gets the maximum when it is going up and going down. So this, at this point, it reaches its maximum. So the point x0 is relative maximum if before the point the function, the slope is positive, and after this point the slope is negative. If you revert this concept, the second point comes. That is, before the x0, with the function is first derivative is negative, f prime is negative. After this function point, the first derivative is positive, then the curve is like this, decreasing and then increasing. So it should be relative minimum at this point. So we will check the signs of the derivative, first derivative, on both the sides of this point, x0 critical point, and then we analyze it is increasing or decreasing, and then we will decide is relative extreme, relative minimum or maximum. Third point, what is it? If f prime of x has same sign on both the sides, then f does not have relative extremum. If you find both the sides it is increasing or decreasing continuously, then this point is neither maximum nor minimum, like this one, isn't it? Curve is going like this at x. There is a critical point, but still there is no minimum, maximum. Okay. This is second derivation. So first derivation test gives an idea by analyzing the slope of the function left and right side of the critical point, isn't it? And now here second derivative test says a different way to check relative extrema. what is happening here? First derivative is 0 at the point, so we get a critical point x0, and second derivative is positive at this particular point, at this exactly point, not up, right or left. At the exact point, second derivative is positive, then you get relative minimum opposite to positive, then it's minimum. If it is negative, then it is maximum. If it is 0, the test is inconclusive. This method fails, isn't it? So there are two methods now. First derivation test analyzes the slope in the left side and the right side of the critical point x0. That is first derivative test. Second derivative test exactly checks the second derivative value of this point, and if it is negative, you get maximum. If it is positive, you get. If it is negative, you get maximum. If it is positive, you will get minimum. This is what we are going to do. So when second derivative is okay, let's see geometry implications of multiplicity or these things when we analyze the graph. Now let's solve this kind of problems at first. Okay, so we will go to exercise problems and then we'll be back to this one later. Exercise set to 4.2. What is the question? Locate the critical points and identify which critical points are stationary points. What is the definition of critical point? The points at which the first derivation does not exist. If exists, it is 0, isn't it? Does not exist in first derivation cannot be infinity, and if derivative exists, it's 0. So we have to take the denominator and numerator everything to 0, right? Let's try. First problem number 8. Problem number 8. First derivative is 4 into 3, 12x to the power 3 plus 12. Let f dash of x is equal to 0, because first derivative exists. So if exists, it should be 0. If it does not exist, then still the point is a critical point, isn't it? First derivative is possible. This is a polynomial, so this is differentiable. Okay. What do you get? 12 is common. X cube plus 1 is 0. So x cube plus 1 is 0. X cube. X cube is negative 1. So one of the roots of this equation is negative 1. X is negative 1 is the only real root of this equation. Other two roots are complex roots. So x is negative 1, isn't it? So x is negative 1 is the only critical point. And of course at this point first derivation is 0. So this is a critical point, and of course it is stationary point. So critical point is x is equal to negative 1, also stationary point. So remember, stationary points are those points at which first derivative is 0. But critical points are those points at which the first derivative is 0, and of course first derivative may not exist. Let's see it, the second case, problem number 10. Problem number 10. Differentiate it by using quotient rule, isn't it? What do you get? V x cube plus 8. Differentiate x square, it is 2x minus x square into differentiate x cube plus 8, 3x square divided by x cube plus 8 whole square. Simplify it, you get v du. So this is x cube plus 8. When you differentiate x square, it is 2x, okay, and then x square is cubed to differentiate x cube plus 8 is 3x square, okay. Now simplify this one. x cube plus 2x, multiply this one is 6, 2x raised to 4 plus 16x minus 3x power 4 divided by x cube plus 8 whole square. So when you simplify, first derivative will be 16x minus, so minus 3 minus x power 4 plus 16x divided by x cube plus 8 whole square. So if you want to find at which first derivative is 0, we should take the numerator to 0. If you want to find the points, the values of x at which first derivative does not exist, take the denominator to 0. So denominator to 0 gives x cube plus 8 is 0, x cube is negative 8, x is minus 2 is only one real root. So denominator 0 gives x is negative. So x is negative 2, first derivative will be infinity. So at x is negative 2, first derivative does not exist. But the function, see, remember, function is not defined for x equal to negative 2. So we don't need to analyze x equal to negative 2 because we need to analyze those points at which a function is defined. So first x is negative 2 is not in our equation because the function itself is not defined for the value. So the critical point should be the point at which the function, original function, defined. So f dash, if the function is not defined at negative 2, so we don't need to worry about this denominator 0. So only thing, take the numerator to 0. What is it? Numerator is 0, 16x minus x power 4 is 0. Take x outside. This is 16 minus x cube is 0, isn't it? So this gives x is 0 or x cube is 16. X cube is 16 gives x is 16 to the power 1 by 3. So there are two values, x equal to 0, x equal to 16, 1 by 3, at which first derivative is 0. When you take numerator into 0, you get stationary points. Every stationary point is critical point, isn't it? So we know that these two are critical points and stationary points. X equal to 0, x equal to 0, this one, and x equal to 16 over 1 over power 1 over 3. These two are stationary points and of course critical points, right? So let's see problem number 12. Problem number 12, differentiate it by product rule. Keep the x square, differentiate the power 2 by 3 into x minus 1 to the power minus 1 by 3 plus x minus 1 to the power 2 by 3 is kept. Differentiate x square, will get 2x. Now simplify. This is first derivation actually. What do you get? 2x square divided by x minus 1 to the power minus 1 by 3, 3 in the denominator. Second term is 2x into x minus 1 to the power 2 by 3. So now cross multiply this one with this one. What do you get? This 2x square, 3 into 2x, it will be this 3 into this 2x, it will be 6x. And x minus 1, x minus 1. Power is, this one is, so this is positive. When the denominator, when you write in the denominator is 1 by 3 is positive. Power is 2 by 3 plus 1 by 3. It will be 3 by 3. Power will be 1. And the common denominator is 3 into x minus 1 to the power 1 by 3. So you get 2x square plus 6x into x minus 1 divided by 3 into x minus 1 to the power 1 by 3. So you will get first derivative of x when you simplify this one. 2x square plus 6x square, 8x square minus 6x. 8x square minus 6x divided by 3 into x minus 1 to the power 3. Which is, when you take 2x it will be 4x minus 3 divided by 3 into x minus 1 power 3. So this is our first derivation here, and the first derivation at which, see, x is go back to the given function. This is the given function. Function is defined at x equal to 1. Even if you substitute x equal to 1 here, it will be just 0, not infinity. So function is defined at x equal to 1. So we can consider the denominators also. First derivative does not exist when x equal to 1. You see, when x is equal to 1, first derivative will be infinity. So x is equal to 1 is a critical point. Critical point is the point at which the function has been defined but first derivative does not exist, or if exists it is 0. But here the denominator is 0, so the function first derivative will be infinity at x equal to 1. So x equal to 1 is critical point alone, not a stationary point. For finding another critical point and stationary point, take the numerator into 0. Numerator to 0. What do you get? 2x into 4x minus 3 is 0. 2x gives x equal to 0, 4x minus 3 gives x equal to 3 over 4. So these two are critical points and the stationary points. And the first derivative will be 0. Those points are stationary points, isn't it? So every stationary point is a critical point. So x is equal to 0, 3 over 4 are stationary and critical. But x is equal to 1. X is equal to 1 is only critical point, because at x equal to 1 the function, the derivative does not exist, but not the function, derivative does not. So critical point is the point at which the derivative does not exist if x is 0. So these 2 points at which derivative exists and 0. So these points are called stationary points as well. That's it. Let's see the next set of problems. Use the given derivatives. So you are given first derivatives. 3 problems with the first derivative. Use the given derivatives. Find all the critical points of the function. Critical points. They never classify into stationary or critical. Just critical points. And at each critical point, find the relative maximum, relative minimum, or neither. So only first derivative test we are going to use, because we are given first derivatives. So we are going to use first derivative test. Okay, and assuming that this is function, original given function is continuous everywhere. So at every point a function has been defined. This is the derivative. So we don't know actually what is the original. When you integrate this function, you will come to know what is f, but we don't want to know. We have been assuming that we are allowed to assume that f is continuous everywhere, right? Okay. Now let's take question number 25. How to find critical points? Critical points are those points at which first derivative is 0 or does not exist. Here first derivative exists, so take it 0. X square is 0, x cube minus 5 is equal to 0, isn't it? So x is 0 is first point. X cube is 5, or x is equal to 5 to the power 1 by 3. 5 to the power 1 by 3. So we got 2 points now. What is 5 to the power 1 by 3? In calculator we can find it. What is the exact value of 5? It's coming around 1.71, isn't it, approximately? So you draw the real line. We got 2 points, x equal to 0, x is equal to 5 to the power 1 by 3. This is equal to around 1.7. So we have to choose some values lesser than the 0. So first derivative test says analyze the signs of the first derivative before see left side and right side of the critical point. For 0, let's take x equal to negative 1. So what is first derivative at negative 1? Is it positive? Check here. Negative 1, this is 1 minus 5, it is negative. negative here. So first derivative negative function is decreasing here. The right side of 0, take 1, you can take. So f first derivation of 1 you can use here. 1 minus 5, again negative, so it's still decreasing. So neither, so both the sides, if you find one side is decreasing, another side is increasing, you can find maximum or minimum at this point, isn't it? Okay, and both the sides is decreasing, so this is neither. At this critical point x equal to 0, we neither find maximum or minimum because both the sides are decreasing. If left side is decreasing, right side is increasing, then you can find minimum here. That's not the case. Let's try. We know the left side of, now take left side of 5. See, it's decreasing, we have found it decreasing. The right side of 5 power 1 by 3. Take some value, which is, let it be 2. So f dash of 2, go to this same equation. First derivative, x equal to 2. What is it? 2 square is 4 and 2 cube is 8 minus 5. So positive, you are getting positive here. So to the left side of 5 to the power 1 by 3, it is decreasing, but to the right side it is increasing. So this is the relative minimum. So at x is equal to 5 over 1 by 3, we get relative minimum. But x equal to 0, neither maximum nor minimum. So let's try problem number 28 in the similar way. There are 2 more problems. I would try only 28, then I leave to you. Problem number 28, first derivative is given. We know denominator can never be 0 because x is square. Even if you give negative value, square will make it positive. So plus 4, it will be positive. So denominator is non-zero. You cannot find a critical point from the denominator. So only possibility is take the numerator into 0. Let x square minus 7 is 0. That is the way to make it. So when you take let f prime of x equal to 0, you get obviously numerator 0. So x square is 7, x is plus or minus square root of 7. What is the exact value of square root of 7? It is something around 2.6445, isn't it? Okay. Now let's draw the line, real line. This is negative infinity, positive infinity, and here it is negative 2.6. You call it negative root 7. Here it is positive root 7, which is 2.645, isn't it? So now we need to choose some values which is lesser than negative 2.65 and greater than negative 2.65, which will be lying in this interval. From in these 3 intervals, we are going to choose one value each. So here, let us choose negative 3, f prime of negative 3. Negative 3 is certainly lesser than negative 2.6. Substitute in this value, 28. X is negative 3. What do you get? F prime of negative 3. Negative 3 square is 9 minus 2 minus 7 divided by positive number. This is positive. This is positive. So this is positive here. Function is increasing. Here between negative 2.65 to positive 2.6. Obviously 0 is here. So let's take 0. F prime of 0. When you substitute 0 here in this equation, it will be 0 minus 7. Denominator is always positive. So this is negative. You get it is negative. So function is decreasing. See, this is the point of discussion to negative root 7. In the left side of it, function is increasing. To the right side of its function is decreasing. So function is going like this. There is a concave down. So it at this point x equal to root 7, negative root 7, the function gets a maximum, relative maximum. So write down x is equal to negative root 7. We get relative maximum. And try the right side of positive root 7. Is around 2.67. So take 3 here. f prime of 3 is again positive or negative. But check here the same equation. What is it? 3 square is 9 minus 7 is 2. So numerator is positive, denominator is always positive. It is positive. Positive, so it is increasing again. So this point you will get a relative minimum. So at x is equal to positive root 7, we get relative minimum. That's it. That's the end of this problem. Try that yourself. The solutions are being given here in this table. Now find the relative extrema using both first and second derivative test. We have seen first derivative test right now. There are two problems, and let me do one problem by using first derivative and second problem by using second derivative. Let me use first derivative test for first problem. F dash of x 8 minus 6x. When f dash of x equal to 0, you get 8 is equal to 6x. X is equal to 8 by 6, which is 4 over 3. So x is equal to 4 over 3 is the critical point here. Critical point. So draw the line. This is negative infinity, positive infinity, and then you take one point x is equal to 4 over 3. 4 over 3, which is 1.3 something, isn't it? That is, you can exactly write 1.33. So left side you can take 1, f prime at 1. What is it? F prime at 1. F prime of 1 is 8 minus 6. It is positive. So function is, this is positive here, function is increasing. On the right side you can take 2, because 2 is greater than 1.2. So you can take here f prime at 2. You can try f prime of 2, which is 8 minus 6 into 2, which is negative. Negative function is decreasing here. So at this point we get, at x is equal to 4 over 3, we get relative maximum. This is by first derivative test. Should I use second derivative test for the same problem to check whether this is true? What is second derivative test? Second derivative, if it is relative maximum, second derivative should be negative at the critical point. So critical point is here. What is second derivative? Let me check. First derivative, okay. Second derivative is minus 6. Minus 6 is negative, obviously negative. So this is second derivation is negative, then obviously at this critical point, whatever the x value, you will get for second derivative negative. So you will get relative maximum. If second derivative is positive, it will be relative minimum. Try 36 yourself. You can use both the methods or any one of the methods. This is it. You have to try the remaining. Use any method to find relative extrema. One more problem I will solve. Let me solve 47. Which method is good? Let me, any method. So let's use second derivative method. F prime of x, differentiate it, you will get e raised to 2x, and then differentiate 2x, you will get 2 minus e power x. Take it to 0. Take it to 0, you will get left f dash of x equal to 0. This is 2 into e power 2x is equal to e power x. At this point, what value will make them equal? X is e power 2x. Okay. Actually, we know that this is 2 into e raised to x whole square into e raised to x. So it will be e raised to e power x. E power x can be divided on both sides. It will be 1. It will lead to e raised to x is 1 over 2. So when e raised to x is 1 over 2, what is x? Take ln on both the sides. This side we will do it. ln the power x is equal to ln 1 by 2. So this is x is equal to ln 2 inverse. X is equal to negative ln 2. First derivative has been taken to 0, found x value. So this is the critical point, Cp. X is equal to ln 2. Now let us find second derivative from this one. So what we found for problem number 47, first derivative of x, which was 2 into e power 2x minus e power s, and we found critical point Cp. X is equal to negative ln 2. Okay, now second derivative f double dash of x. We use second derivative test to check the maximum and minimum. Differentiate the first terms, 2 e raised to 2x, again 2 minus e power x. So this is 4 into e raised to 2x minus e raised to x. This is second derivative. Now use the critical point in the second derivative, negative ln 2. X is negative ln 2. 4 times e raised to 2 into negative ln 2 minus e raised to minus ln 2. This first term will be, this negative and 2 will be in the power. So 4 into e raised to ln 2 power negative 2. Ln and e will be 1. Here e raised to ln 2 inverse. It will be, first term will be 4 into 2 power minus 2. Second term is e and ln will be cancelled, 2 power minus 1. That is 4 into 2 power minus 2. 2 power minus 2 power minus 2 is 1 by 4 into 4 is 1 minus half. The answer is half. So second derivative at negative ln 2 is half. It is positive. Second derivative is positive. We get relative minimum at x is equal to negative ln 2. That is it, isn't it? So if you want to find the minimum value, substitute the x equal to negative ln 2 in the original function. So f of negative ln 2. So minimum value, what is the minimum value? Minimum value of function at the point e power 2 times negative ln 2 minus e power negative ln 2. What do you get? This will be 2 power minus 2. This will be, second term will be 2 power minus 1. So 1 by 4 minus 1 by 2. The answer is minus 1 by 4. So this is minimum most value is negative 1 by 4. So if they ask what is the minimum most value, we will substitute the x value in the original function to get the answer. Try the other problems yourself. And the next problem is about sketching the polynomials. We will see in the next video. Thank you.